The broadcast is now starting. All attendees are in listen-only mode.
This is Parker Yates of DevOps.com. We'd like to welcome you to another DevOps.com webinar. Today we have a really interesting discussion about the 2017 State of DevOps report. It has some real great information that's very factual. And our two guests today are Anders Wallgren, CTO of Electric Cloud, and Jez Humble, who you may know, DORA CTO and author. And Jez has been one of the original people in the beginning of DevOps. Jez, take it from here.
Thanks so much. Thanks everyone for joining us today. Thanks to DevOps.com for hosting us, and Anders and the Electric Cloud team for sponsoring the State of DevOps report. We're very grateful. We're going to talk today about some of the results from the 2017 State of DevOps report, and then Anders is going to lead a discussion on why microservices are important, what they give you, and how you can take your horrible big ball of mud in production right now and turn it into something that actually helps you deliver value to your customers frequently and reliably. So I'm going to start by talking about the State of DevOps report, and if we could just skip forward a couple of slides, what DevOps performance is and why it's important. So I've been working on the State of DevOps report with Dr. Nicole Forsgren and the Puppet team and Gene Kim for 4 years now. We've got a large amount of data, over 25,000 responses by now from hundreds of companies worldwide, and those responses cover all different kinds of companies. Very small companies to very large companies. 25% of our responses come from companies with 10,000 or more employees, all different kinds of domains, not just technology companies, but highly regulated companies, including insurance, healthcare, government. These results are not just small web companies. What I'm going to tell you applies to all different kinds of companies of all different sizes. So I think the most important result is something which has been shown time and time every year, which is that high-performing teams are not trading off moving fast for low stability. We're used to thinking of this idea that if you're going to move fast, you're going to break things. Unfortunately, there are people who do that, but this is not what we see in the data. What we see is that high performers are not only going faster, they're also creating more reliable and stable systems. So if we want to look at the numbers here, what we can see on the next slide is that in 2016, we're seeing that the high performers are going 200 times more frequent releases than the low performers. They're moving nearly 3,000 times faster in terms of lead times because they're releasing in hours, or they're going from check-in to release in hours rather than weeks or months. They can restore service much more quickly in the event of an outage, and their change fail rates are much lower. When they push changes out into production, they're much less likely to have to remediate in some way. And in 2017, we see the gap is closing somewhat, and that's true for the throughput stuff, but the stability stuff, we're seeing the gap is not closing. We're seeing that what's happening is the low performers are moving faster, but they're not yet actually finding ways to create more stability, and they're not putting in the work to actually make sure that those fast releases are more stable. And you see that when companies are like, we must go faster, but we're not going to invest in test automation and deployment automation. This is the result. You end up going faster, but actually breaking things because you've got to do the work of actually improving the culture and implementing the practices. So in terms of, I've talked about high, medium, and low performers. We've seen this every year. We don't tell the stats analysis package what we're looking for. We just say divide it into 3 groups. And what comes out every year is that the high performers, we have a high performing group that's doing really well on all those things, and a low performing group which is doing badly. And what you see this year, high performers are releasing multiple times per day on demand. They can get changes from version control into production in less than an hour. And that's not just for emergency changes, that's for all kinds of changes. When there's some kind of service degradation or an incident, they can restore service in less than an hour. Their change fail rates are relatively low, and for the majority of them, they're in the kind of 1 or 2% range. Low performers releasing, once a week or once a month, more towards the once a month range. It takes them about that long to get changes out because they're batching up those changes into releases. And then if there's a problem in production, it takes them like a really long time to fix that, between a day and a week. And if you imagine your service is out for more than a day, I mean, that's terrible for your business. And when they push changes out, they very frequently have to remediate those changes. One of the things that we looked at this year was manual work and automated work. And this is one of these things where you have to actually ask people. You can't find out what percentage of your release is done manually by looking at your systems data, because your systems data only tells you the automated parts. So we asked people how much manual work they're doing for configuration management, for testing, for deployments, for change approval processes. And what we find is consistently the high performers doing much less of that work manually. They've automated big chunks of it. And that is a key piece of what enables them both to move fast and to create more stable releases. You know, a great example of this is testing. If you can self-service a test environment on demand at the push of a button, that allows you to get much faster feedback on whether what you're building is actually going to work in real life. So that's a great example of a practice which is really good in terms of creating higher quality and higher stability. That same capability that allows you to self-service deployments on demand is what allows you to achieve higher levels of throughput as well. So that's a great example of a practice which contributes both to higher throughput and higher stability and higher quality. We looked at a bunch of different capabilities over the years. These are the capabilities we looked at this year, and I really recommend going back to the other State of DevOps reports. If you go to DevOps-Research and click on the Research tab, you can access all the historical State of DevOps reports. This year we looked at the impact of leadership practices, transformational leadership on the technical practices and on lean product management. And what we found is that leadership matters. Having leaders where they care about actually supporting their teams, giving their teams intellectual stimulation, actually inspiring their teams with a vision and a mission of what's important that they're working towards, rather than here are the features you're working on this week. That actually matters. It actually impacts your ability to implement the practices. And as in previous years, we found that the practices are important. Implementing things like trunk-based development, building security into the development process, those technical practices are important, and also a bunch of product management practices are important. So team experimentation, which I'll talk about a bit later, working in small batches, gathering and implementing customer feedback, all those things impact both IT performance and organizational performance. And as in previous years, we found that IT performance matters. Achieving that high level of IT performance that we saw, where you're releasing frequently, you have more stable systems, that impacts organizational performance. So traditionally, we've measured organizational performance in a commercial context. Are you achieving high levels of productivity, profitability, market share? And as with previous years, we found that high performers are twice as likely to achieve those objectives. So people achieving high performance in IT are twice as likely to achieve those commercial goals in terms of productivity, profitability, and market share. But we also wanted to look at non-commercial organizations that are mission-driven, non-profits, the government, and we found actually very similar results. We were looking at the quality of the products or services they build, their operating efficiency, customer satisfaction, the quality of the products and services they're building, whether they're able to achieve their mission goals. And what we found is, again, that high-performing organizations were twice as likely to achieve those kinds of goals. So this works not just in the commercial context, but also in the context of non-profits, the government, non-commercial organizations. We're seeing the same impact. This year, we did a deep dive into architecture and the impact of architecture on continuous delivery. And what we found actually is that architecture is the strongest predictor of the ability to practice continuous delivery, stronger than test automation, than deployment automation, than continuous integration. The biggest thing you can do to impact your ability to do continuous delivery is focus on your architecture. And what we were particularly interested in was the outcomes. So a lot of people, when they think about architecture, they think about, am I using Kubernetes? Am I using Docker? And what we found is actually that outcomes are what's important. So the high performers in terms of architecture are the people who can answer yes to these 5 questions. Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Can my team complete its work without fine-grained communication and coordination with people outside the team? So those are two capabilities that speak to the organization, the structure, the communication within the organization, information flow within the organization. And then 3 more technical capabilities. Can we deploy or release our service or products on demand independently of other services the product or service depends on, which basically is, do I have to do big bang orchestrated deployments where I push everything together because I can't push individual things, or can I just push individual products and services on their own? Can my team do most of its testing on demand without requiring an integrated test environment? Can developers create a sandbox, stand up an individual service and run tests on their local workstation and get a good level of confidence that their software is actually releasable? And then finally, can my team perform deployments during normal business hours with negligible downtime? Still, my biggest test to validate if you're doing continuous delivery is, how much time do you have to spend outside business hours doing releases? Are you doing releases evenings and weekends? Because if you are, you're not doing it right. That's not continuous delivery, and that's fundamentally an architectural problem. We should be able to do releases at any time during normal business hours at the push of a button, and that should be a totally routine, boring activity that we can do whenever we want. So what we found is that teams that could answer yes to these questions, they were the ones that could practice continuous delivery and achieve these IT outcomes. And for me, one of the most interesting things about this is it demonstrates the connection between the organizational structure and the technical capabilities. We saw that there was an organizational aspect to this. Can teams get stuff done on their own? And can teams actually deploy stuff without relying on other teams? Well, those 2 things are connected, and this is what Conway's law tells us. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. So what that means is, you've got to design your architecture to match the communication structure of your organization. You're not going to have those 2 things in conflict and be able to get stuff done. And the final point that I want to make about architecture, which I think is so important, is those architectural outcomes that we talked about, you can achieve that with mainframes. Equally, you could have the latest trendy Docker, Kubernetes, microservice architecture and not achieve those outcomes. And if you do that, you've kind of failed. People focus a lot on the tools, and you know, I'm not going to say tools are important. Don't get me wrong. It's important to have good tools. But if you have the good tools, but you don't use them in the right way and you don't achieve those outcomes, you kind of wasted your money. So the last thing I want to talk about is product management and product management capabilities. We found this year that product management capabilities drives organizational performance, both in those commercial terms, profitability, market share, productivity, and in a non-commercial context, things like the ability to drive the mission, to produce high quality products that satisfy customers. In previous years, we've looked at some important lean management practices, things like working in small batches, making the flow of work visible through the process, gathering, broadcasting, and implementing customer feedback. And what's most interesting about those is you have to do them together. What we found is that, you know, just making the flow of work visible doesn't necessarily help you. You've got to do that in combination with the other things as well. It's the combination of things that helps you. This year, we added to this idea and we looked at the impacts of teams being able to try out new ideas and create and update specifications without requiring the permission of other teams. I'm sure all of us have seen so-called agile organizations where the Scrum teams are still fundamentally taking orders. You know, here are the features that you're delivering. Why are we building these features? Never mind that, just go and build them. So I discovered implementing this, that this is going to be really hard to implement. And if we change this thing, actually, it's going to be much easier and it'll probably be better. No change in the specifications, that's not allowed. So, you know, TLDR, that's not agile. If the teams don't get input into the design process and teams can't change the specifications in response to what they discover in the course of building it, you're not agile. The whole point of agile is that we can change the plan in response to what we discover when we're building something. And so we asked this question, can you try out new ideas without getting permission from some other team or your managers? Can you make changes to the specification based on what you discover? I mean, not just because you want to. I mean, we're not advocating, do whatever you want. We're advocating, I learned something, here's the data, here's what I discovered. Can I then change the specifications? And we find that's important, that actually has an impact on your outcomes in terms of profitability, market share, productivity, high quality products, delivering the mission. So these things matter, they are important. If you're in an organization which is like we're doing Agile, but you're still fundamentally order taking, you need to think about that and what you can do to fix that problem. So that's a very high level. Sorry, go ahead. You're going to say something, Anders?
Nope.
Okay, cool. So that's a very high level picture of some of the results from this year. I really recommend getting a copy of the report, reading it. You can go to puppet.com/state-of-DevOps-report, get your copy. You can also go to devops-research.com. That's my company's website, DevOps Research and Assessment, and download previous year's copies. We have a book coming out end of this year, beginning next year. Me and Nicole Forsgren are writing a book which summarizes the results from the last 4 years. That's going to be coming out. If you come to the DevOps Enterprise Summit in San Francisco, this I think it's either October, November. So that's an event that's put on by Gene Kim and Electric Cloud. You'll get a copy of that book when you register. So good thing to sign up for. And that's my spiel on the State of DevOps report. I'm going to hand it over to Anders.
Awesome, thanks. And I mean, I'll reiterate too, if you haven't looked through the State of DevOps reports over the years, you're missing out on a really good tool to help evangelize, convince people, back up your anecdotal data with tons of really good data. It's a great tool. I hit people over the head with it all the time, and it works. So do a little bit of talking here about microservices, which we just talked about loosely coupled architectures, and the one thing that we're seeing quite a bit with our customers and prospects is culture tends to be a very important thing to get right to do DevOps and Agile well, but it's neck and neck with product architecture, especially when you're dealing with existing or quote unquote legacy applications. I kind of dislike the word legacy because I think it's come to mean code that I didn't write. That's somebody else's problem. I can't be responsible for that. But if you have existing product and it's not loosely coupled architecture and it's not set up so that you can deploy pieces of it independently and things like that, that really does hurt your ability to get your velocity up and your cadence and reliability and those kinds of things. So I want to focus a little bit on microservices, which is certainly on the top of a lot of people's minds these days, and one of the most obvious ways to go about doing a loosely coupled architecture. So I'll just define microservices as what's on the slide here: a suite of services, each service focused on doing one thing well. Runs in its own process, has an API that's exposed. Most common we see REST-based APIs, those kinds of things. But that's if that works for you, great. If you have a better way of doing APIs, go for it. Two of the most important aspects of this is that they're independently developed and they're independently deployable. So really what we're trying to get out of the loosely coupled architecture here is to not have coupling, right? I don't need another team's permission or coordination in order to develop, test, qualify, and then release and deploy into production these services. So that's kind of just the little spiel on what they are. Now, what's so cool about them? Well, it's a divide and conquer thing fundamentally, right? We're breaking a complex problem into constituent pieces, each of which have their own thing to work on, and that allows us to throw people at the problem a little bit more. I'll talk a little bit about the impact this has on things like the mythical man-month complex that we all deal with. They're loosely coupled, which is good, and one of the things not to ignore is it makes it a lot easier to adopt new technologies. If you keep in mind what you're doing with a monolithic application, you're probably using one single tool chain. It's all Java, it's all C++, or it's all Python or PHP or what have you. And you don't really necessarily have the ability at that point to choose the right tool for the job. And I realize what I said here is, make it easier to adopt new technologies. That doesn't even have to be new technologies. If you're using a monolithic architecture, you don't even have the ability to adopt old technologies. With microservices, build one in Java, build one in Python, use whatever is the right tool for the job. And that really gives you a lot of latitude to architect things right. And that a side effect of building in microservices is that we're able to build them using smaller, more autonomous teams. And it's been shown over the years, for quite a while now, that smaller teams are more productive, right? You don't have as many communication and coordination things that you have to deal with. Decisions can be made more quickly, those kinds of things. So in general, being able to do these kinds of things are good. Now,
I just want to jump in here and quickly say, that this. I was working in the US federal government last year at 18F. We built a platform as a service called cloud.gov. So that was Amazon with a bunch of open source stuff on top of it. That was a team of about 10 to 15 people who built that platform as a service. You don't, and this is true in a lot of even big regulated organizations, you don't need a lot of people to get stuff done, and actually it can get in the way. There's no economies of scale in software development, and in fact there's kind of diseconomies of scale. Yeah,
absolutely. Yeah, I mean, throwing people at the problem is not a good idea in general. Now, to be fair to our friend the monolith, there are certain pros, and I probably should have put pros in quotes here, but I mean, they can be easier to develop, right? I mean, there are a lot of things you have to figure out and do correctly when you're doing distributed applications, like microservices. You have to have APIs, you have to have network, you have to deal with network latency and all of those kinds of things. So they can be easier to do monolithically. They're also much easier to do properly. They can be easier to test because, hey, there's only one thing I have to have up and running, and that's my monolith. As opposed to, in a lot of cases, what people will do in microservices is they'll kind of paint themselves into a corner a little bit where they need to have a bunch of services up and running in order to do testing. Now that may, that probably isn't the right way to go about it, but it's definitely a phenomenon that we've seen out there, that people bog down a little bit and have a hard time doing testing. Monoliths can be easier to deploy. If I have my 4 gigabyte WAR file that I drop into WebSphere, that's sort of fundamentally less work than if I have 150 different microservices that I have to maintain. So there are some pros there. I think the pros are not exclusive to monoliths. You can definitely get a lot of these advantages by just architecting things properly. But we all know the cons. I mean, spaghetti code out the yin yang. Much more difficult to integrate new technologies or even old technologies. Very difficult to onboard people because you have a whole big mountain to climb. And oftentimes you have to understand a lot even to start to understand, a little at details. If you need to scale the application, your monolith, you got to scale everything to scale anything. And that can be really challenging. And same with deployments. You can't deploy anything until everything is ready to be deployed. And again, coupling, right? So the coupling really slows us down.
Now, I think that the one thing I would say in favor of microservices, and there's only one, in monolithic apps, is if you're building an MVP for a new product idea, that's probably where a monolithic app shines in terms of being able to get something done really quickly. But if you actually succeed, you're going to need to pull the lever pretty fast and start re-architecting. Yeah, no, that's absolutely right. And I think the best advice I think in that scenario is avoid premature decomposition. The first thing you should not do is sit down and design the 50 different services that you think you're going to need for your wonderful new dating app or whatever it is you're putting together. Absolutely. My analogy for that is kind of like when people used to set up bulletin board forums in the past, they would often pre-populate them with like 50 different topics for people to talk about. Everybody ends up in the general discussion forum in the beginning anyway, right? So it's wasted effort and it's very unagile, right? Because you're making a lot of pretty important architectural decisions up front if you try to lay out your 50 services at the point in time where you probably know the least about how that stuff should get laid out. So that's definitely a great point. Now, we've made reference to the Mythical Man Month and Fred Brooks, and anybody who hasn't read the book, go read it. It's a small book, a quick read, very interesting.
very relevant still, even though it was written in the 70s at some time, I'm going to say, and pays a lot of homage to Conway's Law in terms of kind of coming to the conclusion that you can't throw people at the problem. That will only make things worse. And we're talking a lot here about, hey, we're going to use microservices and loosely coupled architectures, and can we just throw people at the problem and solve it that way? And so the question kind of becomes, was Fred Brooks wrong? Was the Mythical Man Month kind of off the mark a little bit? And the answer is no, right? I mean, this still holds. If you have a 10-person team and you want them to do twice the amount of work, you don't add 10 people to the team, because those 20 people will probably do a half of the amount of work that they were doing before. I think it's much more a question of pay attention to the team sizes and have separate uncoupled teams, right? The whole point here is they should be working independently. Yes, there's going to have to be coordination, right? You're going to have to, as you start to evolve your services and as those patterns become apparent to you, if you're starting out with a small monolith and as it grows and becomes more successful, you decide how to break things out and so on. You are striving for independent teams that communicate through their APIs only, right? They don't even talk face to face. I think Jeff Bezos at Amazon has basically said, humans aren't going to talk to each other at Amazon anymore. We communicate only through APIs. I don't think he actually said that, but let the meme begin. So Fred Brooks wasn't wrong. You still have to pay attention to this, and that gets a little bit tricky because there are a lot of things you've got to be good at or become good at if you want to, especially if you want to take your existing monolithic application or kind of hybrid application and restructure it. When you have, if you've got 50 microservices now that compose your application, and you don't have, solid continuous integration, automated and self-service testing, automated self-service deployments, then you probably want to worry about those things first, right? Now, those aren't necessarily the same functions, especially within larger companies. So you could probably attack some of these things in parallel. But if you're good at CI, you've automated your testing, you're pretty decent at automated deployments, then start thinking about this. But as Jess said, don't decompose prematurely. Start out with a monolith. That's the best place to be, because you don't want to spend your time moving things around in the beginning, right? You want to build it up enough until it's soup and you can start to discern the patterns, right? I mean, that's something that humans are really good at, is seeing patterns in things. But creating the patterns ahead of time is no good. You're going to want to get good at provisioning, especially for testing. If you want to be able to test effectively, you want to be good at deployment, and it should go without saying, but very frequently I find that when I say deployment, everybody assumes I mean deployment to production. If the only time you do quote unquote deployments into production is into production, you're doing it wrong, right? Your engineers ought to be deploying to some extent for testing or for their own development needs. QA certainly ought to be doing deployments, so they're doing testing. All through the software pipeline, you should be doing deployments of your application, of your services, and treat your pipeline as a feature of your product, because it's a very important one. If you have a bad pipeline, your product is going to suffer. With services and microservices, you're going to have to get good at monitoring. You don't want to suffer from kind of the problem that can happen where an error happens in one service, which gets sent to the people who own that service, who then realize, no, that's a problem with this other service. So 20 minutes later, they file a ticket. By the time you've hopped through 50 services, the end user customer who ran into the problem has grown old and retired. So you have to get very good at monitoring. You have to get very good at kind of quick root cause analysis. One effective technique in particular I'll point out is you want to use things like correlation IDs in all the messages between your services, so that you can correlate, these 50 different API calls that happen in my services were all in the service of this one customer action. I clicked buy, right? That talks to the shopping cart, it talks to the credit card service, it talks to the inventory service, blah, blah, blah. And if there's a problem in there, I'm going to want to track that down as one thing. So monitoring, logging, those kinds of things are very important. And then last on this slide, one of the great things about microservices is it's going to force you, if you don't already have it, to build a good kind of domain and system comprehension, because you can't take a monolith and break it apart, and you can't design from scratch a good microservices-based architecture if you don't have good domain and system comprehension. Which also argues for when you're starting out, you don't necessarily have the best comprehension. So again, don't decompose too early. Let it grow up a little bit. Other things to keep in mind, loose coupling is very important, and you can definitely fall into the trap of every time I make a change to service A, I've also got to change service B, right? Now those things are coupled. You can't release one without the other. You should expect that you're going to have some dependency rippling that happens from time to time, right? And you do have to think about the coordination of, I'm going to add a new big feature, right? New big, great, awesome, killer feature. That, by necessity will probably impact a number of services. So you've got to understand the right way to develop that code, to deploy that code, to test that code. You may want to start at kind of the very back end, the tail end of that sort of dependency chain, the value chain, if you will, for those services. And you may have to build, the back end first, deploy it, have it running for a while, kind of dark functionality, and then start to layer the other things in on top of it. Because you don't want to deploy your great new feature only to not have the necessary services downstream ready to service those new calls. So you do have dependency things that you have to worry about. You have versioning things that you have to worry about. So there are definitely complexities around microservices that you have to manage. But you want to stay loosely coupled, small, tightly focused APIs. Be almost a little bit rabid in how tightly you want these APIs to be done. And at the same time, kind of the flip side of that coin, you want high cohesion, right? Everything in that service should be devoted to one task and one task only, right? Your shopping cart service shouldn't also be serving avatar pictures to the homepage and stuff like that. And that's an important kind of point, because if you split these things out appropriately, you can also take advantage of the fact that your shopping cart service absolutely needs to be up 24/7. Your avatar service, that obviously I think doesn't have the same kind of uptime requirements. I'm going to go out on a limb and say that if you display a generic icon for my face when I log into your service, I'm going to go and then move on and not care. So if you have an hour of downtime while you re-architect or fix something in your avatar service, that's not as big a deal as if your shopping cart service goes down. I'm not advocating that you should build crappy avatar services, but we have scarce resources and we have to allocate them. So this gives you the ability. Microservices can give you the ability to kind of put the wood behind the right arrow. What people get into trouble with all the time is kind of coupling between domain data, basically, right? So you want to be very careful about how you kind of restructure or decompose your data. If you have a monolith sitting on top of an RDBMS, that is probably going to be one of the most challenging things to breaking this thing apart. All of the data relationships and foreign keys, and I have to commit all of this data in one transaction. You really have to start to evaluate, do I need an RDBMS for all of this? Do I need a single RDBMS for all of this? Or are these really separate, pieces of data, separate pieces of domain data that really shouldn't really, be kind of hooked together and coupled this way? And again, if you find yourself changing behaviors and that has to ripple through lots of different services, then that's probably a sign that you want to at some point step back and figure out whether you've got to shift in the way things are working, and maybe you want to shift your services accordingly. Now there are difficulties, in microservices. Distributed systems are hard. You definitely want to go off and read the 7 or 8 or 12 or 42 fallacies of network computing. All right, the network is not reliable. You don't have infinite bandwidth. You don't have zero latency. All of those kinds of things. And it's a little bit of a mind shift to go from in my monolith, I'm making a method call to in my distributed service, I'm making an over-the-wire call. My method call probably isn't going to crap out because the code on the other side doesn't exist right now. But of course, in a distributed system, the code that I'm calling, the service I'm calling, might be overloaded, might be down, all of those kinds of things. So you have to be very resilient in those kinds of things. There's good libraries out there for dealing for providing things like circuit breakers and retries and those kinds of things to make these things easier. State management will be one of the most difficult things you have to deal with, like I mentioned before. Databases and so on will be a challenge. How you handle transactional boundaries, how you handle caching, or well, more importantly, caching consistency, and those kinds of things. That's often where monolithic applications run into challenges when it comes to breaking them up. And then there's just kind of the reality of, okay, I have 50 different services in my application, but I don't have 250 people working on this so that I can have 5 people per service, right? So you kind of, you have to deal with the reality of how much staffing you have, and you may have to sort of live in a world where we're going to focus on this service now, we're going to get it to the point where it works, and then we're going to stop working on that for a while. We're going to move on and work on this other one, because you may not have time to fully staff services. That's just the reality of the way some of these things are. But again, the point of the services is have them be small enough that you can manage that. And you also want to avoid, kind of ending up siloing these teams now that they all have different services that they're responsible for. We don't want to go back to the bad old days of, throwing our code over the fence and, let them deal with it. It's not my problem. And then, of course, legacy apps, existing apps. What are we going to do? Are we going to rewrite them from scratch? Are we going to just ignore them and keep running them the way they are? Are we going to come up with some sort of hybrid approach where we start to kind of fork off pieces of the monolith? Those kinds of things. There's no right answer to that. It's all going to depend on, what's the current architecture, what's the current size, what's the criticality, what's the time frame across which you want to make these kinds of changes, so on and so forth. And again, I'll say it again because it's important. You got to have good system comprehension. Ideally, you've got people who have the state of the world in their head in terms of the way things are laid out, but that's not always the case, and it's not always possible. So you need to pay attention to that. And then one thing which I've seen, which is kind of funny, is people break down their and this is probably more relevant to kind of container deployed microservices. You might have a tiny little service, but if you then deploy that inside of WebSphere running inside of a Docker container, you still have a pretty big footprint for your one tiny little service. So you want to think about that too, because when it comes to doing deployments and when it comes to doing maintenance and footprint and resource utilization and those kinds of things, if you've got a small service, maybe you don't need, and I'm not bashing WebSphere here, but maybe you can run with a smaller, more lightweight kind of container.
I'll bash WebSphere.
Okay.
Sorry, just had to get that in there.
Yeah.
PTSD.
Yeah, no kidding. So, some best practices, and I've been saying decomposing the monolith, and Mirko Hearing from Accenture said, no, decompose. That implies that you're sort of actively in control of this. It's more like eroding the monolith. It's going to take a long time, and these are geological efforts in some cases. But lots of good advice here, which I think is some of it's fairly straightforward, right? Be agile in this effort, right? Look at things like Fowler's strangler pattern in order to start to kind of break these things apart. You will get it wrong the first time. Just assume that you're going to get it wrong and you're going to have to adjust along the way. Don't get too upset about that. Look for seams. Look for places where there are kind of API boundaries. Code that's kind of independent, focused on a single capability, and maybe you'll find some low-hanging fruit that you can start to pull out into separate services. Or look for areas of code that you're changing a lot that might benefit from being in its own service, where you can independently develop it and deploy it and not cause commotion in the rest of it. Conway's law again. Don't ignore the organizational structure because it will. The old adage here of if you make a team of if you make 4 teams and ask them to build a compiler, you're going to get a 4-pass compiler. Just assume that that's going to happen. Domain-driven design, domain contexts, pretty useful mechanism for thinking about this, for thinking about the data, how to structure that, how to avoid those kinds of dependencies that creep up. Dependency analysis tools in the code can help. That can allow you to sort of figure out where you might have islands of code that you can easily extract independently, but they're not going to do the work for you. You want to read Yagei's rant on kind of the Amazon versus Google way of doing things. It's a pretty funny thing. Hopefully we have the link later on in the slides here. If not, just Google for that and you'll find it. It's a wonderful.
I just want to plus 100 that. You can just Google Steve Yeager's platform rant. He talks about all the lessons they learned at Amazon from building a service-oriented architecture, which, by the way, took 4 years. It was a substantial investment. I read that on a regular basis, and every time I reread it, it sparks new ideas. It's great.
Yep. Yeah. No, it's fantastic because it's also kind of balanced. You know, it's sort of here's what we did wrong, here's what we did right. You know, those kinds. I love those kinds of rants that are not just all one-sided. Highly recommended reading. Again, data. It's going to be kind of hard. RDBMSs are often the single largest source of coupling in your application. So if you have an existing application with an existing schema, you're going to have to get, pretty intimate with that schema and understanding where are the foreign keys, where do we have mutable data that's going to live in multiple places, and how do we do consistency, and where are our transactional boundaries? Do we need ACID, or can we be eventually consistent? Don't go down the road of distributed transactions and those kinds of things. That therein lies madness. Think about splitting your data before you split the code. That's a pretty good way of keeping yourself honest, if that's possible. And again, do you need an RDBMS for all of this stuff, or can you use a NoSQL key value flat file? What have you? Yes, I want banks to use RDBMSs when they transfer money into and out of my accounts. I don't necessarily care if Jez's like on my Facebook page shows up before somebody else's like. The ordering that is unimportant. That's a very different kind of problem. So don't treat the RDBMS as the hammer that solves all the problems. Size matters. And reference to Spinal Tap here. If you haven't seen that movie, go see it, or go find it. The smaller a service is, the more potential decoupling benefit you're going to have. But again, the smaller the service is, the more services you're going to have. So there's a little bit of a trade-off there. 500 services. I've seen applications that have that many. 5,000, that might be pushing it. I don't know. You'd probably be pretty good at doing versioning and all of those kinds of things. One guideline I've heard quite a bit is you ought to be able to rewrite one of these services in a small number of weeks with a sort of a 2-pizza team, right? Small number of weeks means different things to different people, but I'm thinking 2 to 4 weeks, anybody ought to be able to rewrite that service from scratch, including testing it, getting it up to speed, and all of those things. And of course, if you're trying to push out an update to a service, but you have to make changes to other services, then there's something in that service that doesn't belong. One of these things is not like the others, and you gotta split those things up or rearrange them. So pay attention to that. Don't let your services become mini monoliths. You want to avoid that and get there. Testing, very, very important. I always tell people, if I'm doing my talk on things like microservices and so on, I ask people to put their hands up if they're doing manual testing still, or exclusively or primarily manual testing. And anybody who puts their hand up, I say, leave the room, stop listening to me, go fix your manual testing problem first. Nothing I'm going to tell you here is going to help you until you figure that problem out. Automated testing, well, automated everything, but automated testing is so key. You need that as the safety net, the backdrop, it's a huge thing to be able to count on your testing infrastructure to keep you honest and to prevent bad code from making it into production. And you always want to think about, unit tests are the best. If you can test something when the unit tests do that, it's independent, it runs fast. You don't have to stand up systems. You're going to have some sort of integration tests and other kind of higher level system kind of tests. But rely on service virtualization, stubbing, mocking, all of these kinds of things. What I've seen very often is that some organizations will have completely independent pipelines for each service, so they can build and deploy those things independently. But then they'll also have some more integrated pipelines where they do some more, kind of higher level testing. Sometimes those are done as a prerequisite to moving on to the next stage in the pipeline. Sometimes they're just something they run once a month to keep themselves honest, those kinds of things. But you want to keep things separated to a great degree. We talk about using separate repositories for the source code and and those kinds of things to make sure that you don't start to have, bleed between the code. Performance testing is going to be more important than it was before, because now you're, instead of making a method call that takes, n nanoseconds, you're going to do over the wire call, which is going to take n milliseconds. So you need to pay attention to that. You need to pay attention to how much data you're moving over the wire. If you're used to just being able to pass an object handle inside of the same process, and that handle points to an object that's 1 megabyte, you look at one field in that object, that's no big deal if you're inside the same process context, and that comes out of the cache or something. But if you ask for that object and have to push it over the wire, all 1 megabyte of it, just to read the 5 characters out of it that you needed, that probably won't scale very well. So you need to start paying attention to those kinds of things. Flaky tests are the devil. Root out flaky tests. Those things will waste so much time for you. It's not even funny. Environments and deployments, very important. Automate all the things. We at Electric Cloud sell automation stuff for a living, so of course I'm going to say that. But I think the numbers and especially some of the stuff in this year's State of DevOps report says, look, automation important. Fidelity of environments throughout the pipeline is very important. You got to get rid of the worked on my machine kind of syndrome. It's amazing how much I hear that phrase still. Some people will advocate very strongly. You want to run 1 service per host. Host should probably be in quotes there, because that could be a container, that could be a VM. It sort of depends on your deployment architecture. But you want to avoid. One of the reasons you're running these things separately is so you can deploy them separately, scale them separately, run them in HA in different ways. And if you're running a bunch of things on the same host, that host goes down, you take a lot of stuff down. You don't really want to deal with that. VMs and containers, obviously, are the way to go. Containers and microservices are kind of like peanut butter and jelly these days. If your CFO hasn't walked into your office yet and asked you why you're not using containers so you can run more densely on the hardware or the facilities that you pay for, he probably will at some point when he figures out that a container is a lot more lightweight than a VM. Think about immutable servers or immutable services. We've seen an increasing use in kind of the methodology of, once we deploy something onto an environment, we throw away the keys. We don't ever touch it. We don't log in. We don't fix. We repave. That's a pretty powerful thing that will help you. That'll sort of eliminate, to a great extent, environment drift, which you want to keep in mind of. Platform as a service solutions can be very helpful, but they can also constrain you. You can definitely get kind of caught up in an ecosystem, and you may not want to be caught up in that ecosystem. So look for solutions that allow you to inject your code wherever you want to run it that day. Release pipelines are going to be very important when you have a bunch of different services that you need to develop and coordinate for automating and orchestrating all of these things. We strongly advocate, as much as possible, having one platform for all of your software delivery, so that you have one pane of glass that you can monitor these things through. Understand what your requirements are and what your process is in your pipeline. What do I need to achieve in order to progress to this next stage? And can I automate that? Do I really need to have these meetings where we all have, release theater, where we all kind of say, yeah, I think we're ready. Can we get that a little bit more metricized, if that's a word, to where it's not a, kind of a theater aspect where we all get in the room and pretend that we know that this thing is ready to go, and instead support it with numbers a little bit and just have the code proceed if it meets those criteria. Again, if you're working in this environment where you want to have kind of one kind of overall system to manage your pipelines, you want to make sure that this is a tool and environment and tool chain agnostic kind of platform, so that you have the freedom to choose the right tooling for the right services, and that you're not in a Java only environment or .NET only environment or some other only environment, that you have choices about this. One repository per service seems to be a pretty good practice. Those things are a little bit easier now that people are starting to use Git quite a lot more. That does tend to make things a little bit simpler to manage. But keep independent CI and deployment pipelines per service, or you won't be able to independently deploy them. You may want to have integrated pipelines for testing and those kinds of things, but you need to have a straight line from the check-in to production, or you're not going to be able to independently deploy that service. So keep in mind, self-service automation is critical. Don't make people wait for environments. We have one customer we worked with for quite a while where they used to use hardware. They then became completely virtualized. Back in the day when they had hardware, the service level agreement for requisitioning hardware was 6 weeks. 6 weeks to get hardware on premise and ready to go. They virtualized, and their service level agreement was then 6 weeks. 6 weeks to get a virtual machine stood up. Kind of missing the point there. Self-service automation is critical. People should be able to deploy environments, deploy testing environments, deploy code, run tests. You should never find yourself in a position where, oh, I have to wait for those guys to X, right? Automate X, make it self-service. Monitoring, like I said before, monitoring becomes much more important in a loosely coupled architecture. You have to kind of be on top of that to be able to do it. Track your artifacts through the pipeline. We know from earlier State of DevOps reports, artifact repositories are a key indicator of kind of correlation with being able to do high performance DevOps and deployments. Security, compliance, all of those things become more important. Make sure those things are part of your pipeline, not something that you only do when you feel like you have the time. Things tend to go very bad when you do that. A little bit on what do you do in terms of, should I pay attention to mean time to recovery or mean time between failure? And the answer is it kind of depends, right? I mean, there is a diminishing point of return with testing. There are some tests that you can't meaningfully do except in production. If my production environment has 100,000 machines in it, I probably don't have a testing environment with 100,000 machines in it. We were working with a very large bank on the East Coast, and they spent a significant amount of money setting up a test environment that was 25% the size of their production environment. So there are some things that you may only fail in production, and so you gotta be good at remediation and those kinds of things. And monitoring, being very good at rolling forward, rolling back, using more sophisticated deployment methodologies like blue-green, canary, phase deployments, those kinds of things. And as I talked about before, not all services necessarily have the same durability requirements. You might be able to take advantage of that. I just always love to pull this tweet up because it's wonderful. We replaced our monolith with microservices so that every outage could be more like a murder mystery. It was Jez with a candlestick in the data center. This again.
That's probably true. I'm in your data. You got to get better at monitoring, or your outages are going to be hellacious. You're going to be chasing your tail for quite a bit. Some closing thoughts. Loosely coupled systems. Jez, love to get your take on this too. It's not necessarily easier to do it this way, but it is absolutely better, and it will get easier over time. Your services are not going to be static. They're going to evolve, split, remerge. It's just expect that. You want to design this for resiliency because you're going to have network services talking to each other. The Hystrix library from Netflix is a pretty decent open source library for doing things like retries and circuit breakers and so on. You want to have some form of kind of centralized system visibility and reporting so that you can keep tabs on this. Be very cognizant of all the fallacies of distributed computing so that you don't fall into those gaps. If you've got service dependencies that are kind of critical, if service A is really critical, you need to run that thing in an HA configuration, make sure it's always up, those kinds of things. Event-based techniques, messaging and events can be a great way to reduce coupling. If you're using your database for messaging, probably you want to stop doing that and kind of go to a different architecture to deal with that, and you'll find that you have an easier time decoupling things. And I'm going to hit us over the head again with the logging and monitoring. Very important, very good. Do it. Keep doing it. Yeah, I think the only thing I'd want to add is this is not something you're going to get done in 6 months.
Oh yeah.
Amazon took 4 years. Netflix did it in 2 years. Netflix was starting much more greenfield than Amazon was. I think you have to accept the reality that effective architecture is evolutionary. There is no end state. Your architecture will necessarily change as your organization evolves. That's okay. Don't let it stop you from addressing problems and diving in now and getting stuff done. Just the key is find some way to pick off something and make progress and keep doing that.
Yeah, a challenging architecture, a bad architecture is, it's like I use this goofy analogy all the time. It's like if you've ever seen a tractor pull, it's a sport, but basically your job is to pull a trailer as far and as quickly as you can until you bog down. And the reason you're going to bog down is that the trailer has a weight. That weight moves. It starts at the back of the trailer, but it keeps moving forward. And by the time it ends up over the kingpin in your rear wheels, you're not going anywhere. And that's what a bad architecture is like. A bad architecture makes it more and more difficult every day. It makes it worse every day. And the longer you wait to start to fix that architecture, the more difficult it's going to be. So start yesterday.
Well, Jez Sanders, thank you. I think that was a very informative webinar and a lot of practicalities people can use. Now, Anders, I'm going to make you feel a little old. This question I've gotten multiple times during the webinar. You're going to get a kick out of this. What is spaghetti code? Take it back a few years, huh?
Yeah. Well, I think of spaghetti code as, if you think about a lump of spaghetti that's kind of all stuck together and you need to sort it out and separate it, it's kind of hard. Spaghetti code is code where, you're making calls outside and behind API boundaries. You're reaching into data structures that you shouldn't really be reaching. There's lack of encapsulation, lack of abstraction. You don't have clean separation of concerns and duties. It's the kind of stuff that makes everything difficult, right? I mean, if you don't have clean API boundaries, how do you enforce security? How do you enforce auditing and logging and those kinds of things? So spaghetti code is it's bad.
It's also hard to understand. I think the reference here is it's also called the big ball of mud pattern. So if you type big ball of mud, you'll probably get Brian Foote and Joseph Yoda's original web page on the big ball of mud or spaghetti code pattern. Go and look at that web page. It's very entertaining as well as very informative.
Now for more serious ones for Anders and Jez. Okay, in starting my DevOps journey, how do I keep developers from going after every new shiny object, meaning new technology? And how do I manage keeping business logic and rules centralized?
Well, I think, yeah, I mean, those are two separate questions, I would say. I think the way to keep developers focused is focusing on the architectural outcomes. So there was a slide earlier on where I mentioned the 5 architectural outcomes, and I'll say it again. You can achieve those outcomes with mainframes or with Java. I'm also not a fan of let's pursue the latest, hottest new technology. Those technologies are great, but you've got to be focused on the architectural outcomes you want to achieve that Anders has always talked about. The other thing to point out is that if you have a loosely coupled, well-encapsulated architectures, it kind of doesn't matter what technologies the teams are using. And so actually focusing on the architectural outcomes lets you be a lot more liberal about what technologies people use, because it doesn't matter so much. So I think, and it's the same thing with process. Like, people focus a lot with agile transformations on, are we following the Scrum process exactly? If you have the correct guide rails in place in terms of having a platform for building and testing and deploying your software, and a service-oriented architecture, you can kind of give teams a lot of leeway in terms of what process they want to use, what technology they want to use, as long as you've got those guide rails in place. In terms of centralizing the business rules, again, I'm not sure that's something you necessarily want to do. The question I'm asking myself is, why do you want the business rules centralized? In a service-oriented architecture, again, we've got bounded concerns. So the business rules for a particular piece of the system should be within that bounded context, within that service. You know, I think I probably need more information on why you're asking that question to answer it. I know,
yeah,
am I missing something here?
No, I don't think so. That's a basic question. And sometimes they're brief and there's more to it and you can't always give the complete answer. But realize, everybody, you know, you'll be getting an email after this webinar with everybody's contact information. So feel free to take the conversation into more depth. And if that makes any sense, you can go further and further. Back to you, Anders, a little bit. With Electric Cloud, how would you recommend someone starts the DevOps journey?
You know, I think the first thing we always tend to focus on is you know, obviously we're in the business of selling you know, application release automation software, so you know, we do focus on that. But I think it's more important to, you know, get people to get an understanding of what their process is today. You know, it's pretty easy to come up with, you know, what's our desired end state. You know, oh yeah, we want to be microservices, we want to use, you know, all the new hotness, and you know, Kubernetes this and Kubernetes that, and so on, which is fine. But you know, as with any journey, it's a lot easier to map out the path if you know where you are today. And it's amazing to me actually how many organizations don't really have a full and complete understanding of the journey that the code takes from, you know, laptop to live. You know, I always kind of think of, you know, I'm showing my age again, but and being sort of culturally isolationist, but if you ever grew up watching cartoons in the US in the 70s, there was this thing called Schoolhouse Rock. And one of my favorite little episodes of Schoolhouse Rock was how a bill becomes a law. And it sort of anthropomorphized a legal bill and how it, you know, kind of goes through Congress. You have to do the same thing with your software. You have to fundamentally understand and kind of do, whether it's value stream mapping or what have you, understand what are all the touch points today where we touch the code and why, and where does it sit and why does it sit there, and what are the handoffs and what are the manual things, where are errors introduced, and because really at the end, what you need to understand is, where is my biggest constraint right now? Because that's really where you got to start working first. You know, your biggest pain point, your biggest source of failure. You know, you really need to start working on those things, you know, first, and do so in kind of an agile fashion. What I've seen fail spectacularly is sort of the, you know, here's our plan for going agile and DevOps. We're going to send people to classes. From now on, everything is microservices, and you know, we're leaving Friday afternoon doing waterfall, and goddamn it, Monday morning we are DevOps, right? That doesn't work. You know, here's our 3-year detailed plan for how we're going to go, you know, go DevOps. That kind of stuff doesn't work. You have to be agile in your transformation. You know, you have to kind of, you have to have a burn down list. You have to have some user stories. You have to have, you know, whatever you know, methodology kind of works for you. Start with your biggest constraint and go from there, because you know, unless you address your biggest and first and most awful constraint, you don't really make any progress. So keep that in mind.
I'm just going to make a quick plug for DevOps Research and Assessment.
Well, Jeff, I want to ask you a question.
Yeah.
Related to Dora, DevOps Research, the company you're a part of. How can they be of value to a company out there? I mean, you do the research. What does that mean? How would it be of value, let's say, for anyone out there part of a company? How could they utilize what you do to benefit them?
Well, I think Anders set me up perfectly. So thanks, Anders. I think our job is to help you find out where you should invest in terms of capability development in order to get the biggest bang for your buck. So based on that research that I talked about at the beginning, we've identified 22 capabilities that impact IT performance that we know from our research actually have a measurable impact on IT performance. We can run surveys on your organization, across the whole organization, find out for you specifically which capability investment is going to give you the biggest bang for your buck right now, compare you against the industry as a whole for those different capabilities. And, you know, it's fundamentally a different approach from the typical, you know, implement the methodology kind of adoption strategy, because it's, you know, what is going to work for you right now? What's the targeted investment that's going to see the biggest improvement for you right now? So that's what we do. You can also go to devops-research.com and look at all the research we've done. It's all there, all the State of DevOps reports. So yeah, thank you.
I'm sorry, I was on mute for a moment. Well, thank you, Jez. Well, anyway, I didn't realize I was on mute. Here I was, sometimes you have that happen because you don't want to, I was doing something.
Yeah.
Anyway, it sounds like a perfect pairing between the Electric Crowd and the research organization. I mean, you can come in and research it and you can fix the problem at the same time. But anyway, that's all from DevOps.com webinar. We want to thank everyone for attending. Everything will be available this afternoon on the DevOps.com site, being all the slides and the recorded webinar. Thank you for joining us. Any questions not answered will be given to the appropriate parties for answer later, and you will receive their contact information. Thank you, everyone. Thank you, Jez, Anders, and have a great day.
Thanks for having us.